Okay, so this time around looking at it's a plumbing question from 2009, and it's based around the plumbing necessary for your bathrooms. We're talking about your sink, your toilet, where the wastewater goes, the different types of pipework, the styles of them, etc. The 2009 paper, question 4, was based around this kind of topic. So we look at it. A main bathroom as shown, the sketch is located on the first floor of a dwelling house. Part A is asking us, using notes and freehand sketches, show 2 design considerations that should be taken into account when locating the bathroom on the first floor of a dwelling house. So design considerations of where the bathroom should actually be. I'm going to go 2 very straightforward ones. The first one I'm going to include is that if you locate your bathroom somewhere on the first floor, you should try and put it against an external wall. So we're going to say locate bathroom against external wall, and the reason for that is that it will allow the bathroom to have a window in it, which therefore allows natural light in. So if you had the bathroom located boxed in between 2 rooms, left and right of it, you're going to have very little space for a window to actually allow natural light in, whereas when you're against an external wall, you can have a window. So to draw a sketch of that, because they ask for sketches with all these questions, we would draw our external wall. So our external wall is going to be a block wall. So we might as well put in a full cavity and insulation, all the usual details. Put in your symbol for blockwork, whatever you're used to doing for that. I just do a dashed line like so. And obviously there might be a bit of insulation in the wall as well. Okay, I'm just sketching this really quickly because I want to keep the videos short enough. Now, where we could locate a window on that, for argument's sake, you could have your window section, let's say somewhere around here. So we put in our double or triple glazing, and we obviously box that off, and then the walls continue down the other side of it. Okay, so no need to get too detailed with your drawing, you're just kind of making the point. And then obviously just make it obvious that that is the bathroom area. So let's say stick the toilet underneath it. Label that just so they know what you're actually drawing. And we put in hand basin as well. Okay, so label up your sketches a bit more. Make sure that the window is labelled, and again expand your answer. But basically the reason is kind of an external wall is going to allow natural light to enter the room. The second design detail that I would put in is the location of the bathroom. I try and keep it away from bordering one of the main bedrooms. And if it was bordering a bedroom, I'd maybe have it bordering like a guest bed or something like that. But the main bedroom should probably be kept away from one of the main bathrooms in the house. And the reason would be just a noise issue. So when you're flushing toilets or when you're having showers or whatever else, it's going to be a lot of noise. Doing it late at night, it's going to keep people awake that are in the bedroom next door. So in terms of how you would sketch that out, what we'll do is we'll stick our bathroom in the corner of the house again. And no need to go into too much detail with what the walls look like or anything else. What we'll do is we'll just divide off. So let's say that's going to be our bathroom area. You can sketch in the same as the last time, the sink, the toilet, the bath, all the rest. Go in a bit more detail than I am here. But what we're trying to make the point is that we have a division between that and let's say whatever the next bedroom would be. Okay, or the main bedroom at least. So that division could be a hallway. It could be a hot press. Or it could be maybe a built-in wardrobe that is part of this main bathroom. As long as there's an obvious, they're not sharing a wall, there's an obvious division between the bathroom area and one of the main bathrooms. And again, the reason for that is noise reduction. So obviously when you're writing this out as a full answer in the leave insert, you expand out all these points, you make your sketches a little bit more detailed, you label them up, etc. But they're the basic points. Now, part B of the question from 2009. Using notes and sketches, show the above ground pipework, so that's the pipework that's actually in the house, necessary for safe discharge of waste from the following fittings. And the two fittings that they mention is the hand basin and the bat. So where does the water go once you put it down the sink or you empty the bat? Where does it go? We're going to draw that pipework now. The best way of doing this out will be to do a cross section of your house. So we're going to have it, remember this is on the first floor, so we'll have a downstairs and then we have a first floor. So a cross section of a house, what we'll do is just put the ground floor, this will be the ceiling of your downstairs, the ground floor of the first floor. We'll stick, let's say, a cross section of a bat, and then what else? They ask for a hand basin. So what we're going to have is we're going to have a main pipe that's taking all of this wastewater. So it's going to flow down and that's going to connect up to your main wastewater pipe going to your septic tank or going to your storage system if you're in an urban area. And we have to do is we have to connect up. Now in the main water pipe, the main wastewater pipe, you're going to have a vent on the very top. So this will be outside the vent. So it goes outside the ceiling or the eaves or whatever else. That's just to prevent a build-up of gases. Now we obviously have a connection pipe going from the sink to this main wastewater pipe. And again we have a connection pipe from the bat going out to that wastewater pipe as well. So if we have any water or waste coming out of those, they're going to flow down into that pipe. Again, just take a little bit more time and put more detail into your sketches. What you could also include maybe would be the direction of flow. So where is the water coming from, where is it going to? So that's going to continue down into wherever your wastewater goes, depending if it's an urban or a rural house. Now we put some details into this. So in order, they mentioned the question for the safe discharge. So the first thing we're going to put in is that you usually have some sort of a shape on the end of these pipes for the sink or the bat, and they're typically known as your P or S traps. So that's the first bullet point we're going to make. Now the way they work is that the P or the S, that's basically the shape that the pipework takes coming out from the sink, coming out from the bat, and the function of that, putting that shape on a pipe, is it forms a seal of water and prevents any kind of odours creeping back up through the wastewater pipe and then coming up through the sink or the toilet or whatever else, or the bat, and it just prevents those kind of nasty smells coming back up. So let's say for argument's sake we had the S trap. This will be coming out of the bottom of your sink and the pipework would be shaped as such. So it's exactly what it sounds like, shaped in that S shape. Now what's going to happen is in this kind of a dwell area, water's going to lie there. So once all the other water has kind of drained down the pipe, you're going to be left with water lying in that curve on the S. And what that's going to prevent is it's going to prevent the gases coming up and getting up through the vent in the sink or the bat or whatever else. So that's your prevention of that. Again, word out these answers a little bit more. In terms of size of pipework, typically for coming out of a sink, you'd have a 32mm white PVC pipe. So 32mm is the diameter. For the bat, you might have slightly larger because there'd be more water coming out in the one go. So you'd need a higher capacity pipe. So for a bat, you would typically have a 40mm white PVC pipe. And again, that's going to go into your main water pipe. And your main wastewater pipe is normally 100mm. And these are all diameters of those pipes. They're going to be on a slight slope, so the slope will obviously depend on the distance, but typically for a slope, for any kind of pipe work that's doing with wastewater, the typical slope is 1 in 40. Okay, so that's as far as I go with part B. Now obviously you stretch out these answers a little bit. Whatever I've been talking about for the last few minutes, you put that down on paper. Part C of that question the last part. Again, using notes and sketches, they want us to show the design detailing necessary to prevent the penetration of sewer gases into the bathroom at the WC. The WC is your toilet. Right, so for preventing gases coming into a toilet, what you want to do is you're going to have we mentioned already, the P or the S trap. So we'll draw a cross section of our toilet. You're going to have your basin, and obviously that's connecting up to your main pipe going out of it. You'll notice in a toilet there's always water resting on the bottom of the basin, even after you flush it. So when you walk into a fresh new toilet, there's water in it already. And what that's doing is it's preventing any kind of nasty gases from coming up. So it works exactly the same as our P or S trap. It's built into the toilet. Okay, so if any gases do want to come up, they're not going to get very far because you have that seal of water, and that seal of water is going to prevent and coming back up. Now also, any of these pipes, like from the sink, the bathroom, or the bath, they're going to the main pipe, which gets rid of everything, as mentioned in the previous part, the 100mm diameter pipe. But as I mentioned before, that pipe is going to have a vent on the top of it. So this will be actually on the outside of the house. I haven't got enough space to kind of extend it too much, but this will be on the outside of the house, up towards the top of the roof. You'd have a vent, and again, that's going to allow any harmful gases to escape up through it and prevent the build-up. Okay, so that's the main kind of considerations with that question.